Okay, this is section 2.4, nonlinear equations. Definitions. Okay, definition. A nonlinear equation is an equation in which the variable may have powers other than 1, be part of a denominator, and or be part of special operations like powers, roots, and exponentials, and so forth. So basically they're the kind of hideous equations. Now back in section 2.3 we looked at linear equations, and we ended up with the section looking at how to make the calculus solve an equation. Now in this section, section 2.4, with the nonlinears, we almost always have to do it with the calculator. So all of our other definitions about linear equations still apply. The idea of solutions and extraneous solutions and so on. The problem is that in general there are not really good techniques that apply to all nonlinear equations that will give the exact solutions. So in other words, most of the time they cannot be done by hand. You have to resort to some sort of numerical technique, and that's what our calculator is going to do. So in this course we'll be relying on numerical and or graphical techniques for solving nonlinear equations. Okay, again, we saw that at the end of section 2.3. So we're going to take a look at a couple of ways to make our calculator solve them here in section 2.4. So the crossing graphs method. Okay, this is the method that was illustrated at the end of section 2.3. Okay, we're going to look at it again with a non-linear example, one that we really could not solve by hand. So again, as the name implies, the idea is to find out where two graphs cross. So as an illustration, let's solve 800 minus 450e to the negative 0.15t equals to 600. Round your final answer to 4 places to the right of the decimal point. So the idea is to graph each side of the equation and then find where the two graphs intersect. We really just need the x-coordinate of the point of intersection. Remember, the calculator is going to give both x and y. We just care about x. Now remember that t will be played by x in the calculator. So notice that our right-hand side is 600, so we'll definitely need to change our window settings. The value of 600 is a y value, so we're probably going to need to change our y max. So I've chosen window settings of negative 10, 55 by negative 10, 750. It appears on the next slide. Okay, so let's go ahead and put that into our calculator so we can play along here. So I'm going to take out the calculator. So window. Come on, window. So the negative 10 is already there. Change our x max to 50. Our x scale is 5. Our y min I leave at negative 10. The y max I'm putting at 700. And I'm changing my y scale to 50 as well. Now, to have the x max be 50 was somewhat arbitrary. Okay, if it turns out it doesn't work, I can always come back and change it. Now when we say it doesn't work, that means the calculator couldn't find an answer. Okay, so, and then quit this. So at least we've got our window set up. Now we quit the screen, and then we're going to enter the left side of the equation and to y1 and the right side of the equation to y2. So again, just get caught up here. So y equals, I've got 800 minus 450 second ln, then negative 0.15x. Okay, let me get out of my exponent. Remember, press enter to go to y2. If you want, you can just use the arrow keys. Okay, and then y2 is 600. Okay. And let me go ahead and quit that screen. Okay, so we quit the screen and then we're going to press second calc. If you wanted to, you could have pressed second calc directly. Okay, and second calc is the trace key. Okay, when you do that, you get these. Remember, we're wanting choice number 5. Okay, so choice number 5. So let me walk you through here. So second calc. I'm wanting to find where they intersect. So choice 5. Okay, now it's going to graph them. Okay, now when it graphs them, if it turns out you don't find a place where they cross, that's a clue that you might need to change your window settings. Now sometimes, even if they don't cross in the viewing screen, the calculator can still find the answer. You don't really know until you press all the other buttons. But if they don't cross, then you might want to say, I'm going to go back and change my window settings so that they do in fact cross. Okay, now remember from section 2.3, it's now asking us, is the first curve, okay, the blue one, is that its equation? 800 minus 450 e to the negative 0.15x? It is, so just press enter. It's now asking you, is the second curve, is the right side of the equation 600? It is. Just press enter. It's now asking you for a guess. Okay, it's saying that it's going to start with a guess of 20. Again, it's as good a value as any. So just press enter. It's now found the answer. Okay, 5.40620014, etc. And remember, we don't care about the y. Okay, but remember, it had to be 600 because that was the right-hand side. So we care about the x. So to get caught up in the presentation here, okay, so we wanted option 5, right? So you can either scroll down to it with your arrow keys or just press 5. Okay, and then it's asking, is that correct for y1? And then it's going to ask you, is that correct for y2? And then it's going to ask you, do you want to make a guess of 20? And same place we have now, so 5.40620014. Now let's say, for instance, it didn't show enough decimal places for you to round. Remember, on the calculator, if you quit this screen and then just press X and enter, remember, there it is with more decimal places. Because remember, the answer is stored in location X. So if you need more decimal places, there it is. So we got all that into 4 places, 5.4062. So there's the answer to that equation. So for an example, we'll look at another method for solving nonlinear equations. Okay, so we've already seen this one twice now, once in section 2.3 and just now in section 2.4. So the single graph method. Now, as the name implies, you're not looking for where 2 graphs cross. You're just going to be plotting a single graph. So the single graph method is used when an equation is set equal to 0. In terms of a graph, that means we're looking for where the graph crosses the x-axis. So this is looking for the x-intercepts. So we illustrate with an example. Okay. Now, before I get started with my example, something that you should get in the habit of doing when you play with all the settings on your calculator, okay, clear this out. Get rid of your y equals. Clear it. Clear it. And quit that screen. And remember, we also played with the window settings, so do zoom and just choice 6 to go back to standard. Okay, and clear that screen as well. Now, if you're really ambitious, you should also maybe clear out your memory. So second, memory, and memory management, choice 2. Let's get rid of any real variables. We didn't have any complex ones. And notice x and y have been used, and they're taking up a little bit of space. So just delete, delete, and you can quit that screen. Okay? So now we're basically back to a clean calculator. So here's the example that we're going to use for the single graph method. It says solve for x, round your final into the 4, place it as right at the decimal point. Okay, now we are going to have to enter that into our y1. So let's just go ahead and take out the calculator and put it into y1. Okay, let me move it over here. So y equals, so 125 plus 12x minus 100 second ln 0.12x, and let me just get out of the exponent, and let me just quit that. Okay, so if nothing else, I have my function into y1, or my equation. Notice I didn't put 0 into y2. You could if you wanted to, but we don't need to. So we're going to enter the function to y1, which we just did. Okay, right, there we are. Okay, we quit that screen with second mode, and we're going to do second trace, which, you remember, that's calc. You get this screen. Okay, remember, before, for the 2 crossing graphs method, we used choice number 5. This time we're going to use choice number 2. We're looking for the 0, okay, because if we think of this as a function, where a function is equal to 0, that's called a 0 of the function. In terms of a graph and equation, it corresponds to an x-intercept. In terms of this equation, we're finding out where this equation is equal to 0. So it's going to be choice number 2. So when the equation is equal to 0, we choose 2, 0. Okay? If we press 2, we get that screen. Notice, it graphs. Okay? It graphs. And remember, we're looking for the x-intercepts. So we actually see some x-intercepts. If we didn't see x-intercepts, we might have to change the window setting or just zoom out. So to get caught up with this screen on our calculator, okay, again, second calc, choice 2. Okay, and there it starts graphing. Now do notice there are 2 places where the graph does cross the x-axis. So our equation actually has 2 solutions. Now again, it's asking you, is that the correct equation for y1? 125 plus 12x minus 100 e to the negative 0.12x. It is. Now it's asking us for a left bound. So let me get caught up here. Okay, notice that there are 2 x-intercepts, right? One on the left, one on the right. Okay, so now the calculus is asking for what is called the left bound of the interval of where we want to search for an x. So if you want to find the x-intercept that's on the left of the y-axis, this side, you want to pick a value for a left bound that's to the left of where it's crossing. So let's see, 1, 2, 3, 4, 5, 6, 7. Okay. So -7 is to the left of that. So you can just key in -7 and press enter. Okay. So let me kind of do it on this. Okay, so to the left of that, -7, press enter. And notice it kind of draws this little vertical line here, and notice you are to the left of where the graph is crossing the x-axis. It's not asking you for a right bound. So you want something that's a little bit to the right of that. So 1, 2, 3, 4, 5, 6. -6 should work. So I key in -6 and press enter. Okay, notice where I'm crossing the x-axis is stuck between those 2 values. If it weren't, then you need to move them. So now it's asking you, do you want to start with a guess of -6? It's as good a guess as any. So I just press enter. Okay, so this value is -6.676816. So to 4 places, see, -6.6768. Okay. So again, going through that, that's what I had when I entered -7. And then I chose as my right bound -6. Okay, and then my guess of -6, it's as good a guess as any. So here we are trapping where the 0 is, trapping where it crosses the x-axis. And again, there's our 0, that's the left, the first 0. So -6.6768 to 4 places. Now let's say we wanted to get the other one. So it's somewhere between, I'm saying 5 and 6, is that right? 1, 2, 3, 4, 5, yeah, somewhere between 5 and 6. So those will be our left and right bounds. Okay, the left bound will be 5, the right bound will be 6. So you got to start all over again. Okay, so if I start all over again, so quit this, then do second calc, choice 2. Left bound we said would be 5. Remember, we've already found that one. Left bound would be 5. Right bound is going to be 6. And it's guessing at 6, so why not? So that one's about 5.2726 to 4 places. So again, I'm started all over again. So I got my 2 answers of -6.6768 and 5.2726. Now again, without a numerical technique, it really is basically impossible to get the exact answer for that. Now, if you wanted to use the crossing graph method for this, you would have just entered y2 equals 0, and then you would have done choice 5. Whether or not it's any faster or not, I don't know. In terms of how much button pressing you have to do, hard to say. So the decision as to which method to use, crossing graphs method or single graph method, it's just a matter of personal choice. If you're saying, I'm always going to focus on the crossing graphs method, because remember, that's almost what you have to do if one of the sides is not equal to 0. Of course, you can always do some extra algebra work and make it equal to 0, but I don't think I'd want to do that myself. So ideally, we use the crossing graphs method when the equation is set equal to 0, and the single graph method when the equation is set, that should say when the equation is not equal to 0. So you use crossing graphs method when the equation is not set equal to 0, and the single graph method when it is set equal to 0. So if you do choose the crossing graphs method when the equation is not set equal to 0, then y1 is the non-zero side of the equation, and y2 is 0. So some examples. Okay, number 1 says, the formula for determining the displacement of a car's engine in, this supposed to be cubic inches, given by this thing. D is equal to n pi sb squared over 4, where D is displacement in cubic inches, n is the number of cylinders, s is equal to the stroke, which is equal to the distance traveled by the piston from the top to bottom of the cylinder in inches, and b is equal to the bore, which is the diameter of the cylinder in inches. So it says answer the following. Find the displacement of an 8-cylinder engine with a bore of 4 inches, a stroke of 3.48 inches. Round your final answer to the nearest whole number. Okay, my slides for some reason is chopped off here on the right. Question B, find the bore of a 6-cylinder with the displacement of 249.01 cubic inches and a stroke of 3.53 inches. Okay, round your final answer to the nearest hundredth of an inch. This is actually Chevy's 250 i6 engine. When we do part A, you'll discover what this one is. So again, up here, the word that got chopped off is cubic. The word got chopped off here is top to the bottom of the cylinder. The word that got chopped off here, 4 inches and a stroke of 3.5. And this is round your final to the nearest whole number. This is 249.01 cubic inches. Round your final to the nearest hundredth of an inch. Okay, our solutions. Okay, we're given, okay, this is part A. N is equal to 8, it was given as an 8-cylinder. Okay, the B is 4, right? Yeah, B is 4. The stroke, S is 3.48. And we're looking for the displacement. Okay, we're looking for the displacement. So we fill in the numbers. 8 pi times 3.48 times 4 squared all over 4. Okay, so we filled in the values into that formula. And then really we just have to do the calculations. Notice there is no equation to solve in this one. So when you do the calculations, you get 349.84 blah blah blah. So again, just to show you the calculations on the calculator. Okay, I guess turn it back on. Quit that screen. Okay, notice my numerator has a whole series of calculations, so let me just do parentheses. 8 second pi times 3.48 times 4 squared. I'm done with the numerator. Divided by 4. So what did I do wrong? I didn't do my times. So let me edit that. Second, enter. I needed to have 3.48. And let me insert times. Yes. So notice before I was squaring 3.484. So there's your 349.84, etc., etc. So to the nearest whole number, 350. Okay. This is GM's 350 V8. Okay. They put it in a lot of cars. Okay, in question B, you're told that's a 6-cylinder, so N is 6. You're told the displacement in this one, 249.01. You're given the stroke is 3.53, and you're looking for the bore. Okay, again, there's our formula. Okay, my line really needs to be moved, doesn't it? So substituting the values, I'm going to have this 249.01 is equal to 6 pi times 353 times b squared all over 4. Okay, now notice I've got a rather large number here, so I probably do need to change my Windows settings, right? So I choose to solve this using the crossing graphs method with y1 equals to 249.01 and y2 being that mess. And of course, b is the x in the calculator. So let me go ahead and enter those things into our calculator here. So clear this nonsense out. Y equals, so clear that out. Okay, y1 is going to be the left-hand side, the 249.01. Press enter. Okay, and the y2 is going to be the right-hand side. So let's see, open parenthesis. Okay, 6 pi times 3.53. Then remember we're going to use x. So x squared, close the numerator, divided by 4. Okay, and let me quit that screen. Now again, the rather large number, I'm going to set my y max to be up to 250. Now since none of the values can be negative, I mean it doesn't make sense to have a negative bore. So the x min and the y min can be I'm setting equal to, I can actually set them equal to 0. So let me go ahead and do that. Let me go ahead and change my Windows settings. So window. Okay, I'm going to keep the x min at 0. I'll keep x max what it is just to see what happens. Keep the x what it is. Y min will be 0. And my y max, I said I was going up to what, 250? Yeah, 250. Right there. 250. Okay, and then second calc, crossing, so choice 5. I do see them crossing up here at the very top. Remember, I chose y max to be 250, and the engine is 249.01, so it's really just a smidge below the top. Okay, that is the correct y1. That is correct y2. That's as good a guess as any. Okay, so 3.8690156. And then if we round to the correct number of places, 3.87. Okay, so to the nearest hundredth, the bore is 3.87 inches. Okay, question 2 says, an open-top box is made from a flat sheet of cardboard that measures 12 inches by 20 inches by cutting out squares that measure x inches by x inches and turning up the edges. So here's your flat piece of cardboard. Okay, I cut out these corners and then I turn up the edges. Okay, so imagine those dotted things being gone and turning up the edges. So originally this was 20 by 12. Okay, in the figure below, the squares with dotted edges measure x inches by x inches. Okay, so this will then be 20 minus 2x, and that'll be 20 minus 2x. Now the volume V of the resulting box is given by this. V is equal to x times 12 minus 2x times 20 minus 2x. Find the value of x that results in a box with a volume of 100 cubic inches. If necessary, round your final answer to the nearest hundredth of an inch. We will actually visit this open top box again later on. Okay, so remember what's going on here. So I want to again find the value of x. I want to find out what size squares should I cut out in order to get a volume of 100 cubic inches. So let me get my calculator ready. Okay, clear that out. My y equals, let me clear that out. Clear, clear, second quit. Okay. Our solution. Okay, we're going to use the crossing graphs method again. Okay, y1 is going to be the volume of the box and y2 is 100 because remember I want to find out what value of x do I need to get a volume of 100. So again, let me put the volume into y1. X times 12 minus 2 x, close parenthesis, open, 20 minus 2x, close. Okay, that's y1. And y2, the volume I'm looking for, 100. Okay. Now, we're going to need to set our windows again. Notice I got a volume of 100. I wonder, could I keep the setting that I had before? Window. Okay, I see nothing wrong with the minimum of 0 for x and the x max. I could probably make this even smaller, but 10 looks good. Basically, half of that, 10. Okay, the x scale, that's fine. Okay, so the y min 0, the y max. Okay, again, I'm going up to 100, so let me make that just a smidge bigger. Let me make it 150. Okay, 150. That'll be good. And now let's do second calc. Find out where they intersect. Choice 5. Okay, now notice since I kept the scale on the y to be 1, notice how crowded the little tick marks are. Okay, now notice there are two places where this happens. Okay, there are two places where it happens. So my y1, is that correct? Yes. Is my y2 correct? 100? Yes. Now, this is where it's going to matter. What is my guess going to be? Okay, what is my guess going to be? Okay, the first guess is 5. Okay, notice that's going to find, or it should find, the value of x that's on the right. So let me just press enter. Oh, it turns out it's exactly 5. What an amazing coincidence. So one choice is to have x be 5. Now, how can I find this one? Okay, how can I find this one right here? So let's do calc again. Let's do choice 5 again. That is the same y1, same y2. Now, let me change my guess. I want to get this one way over here. Remember, each one of these tick marks was 1, so let me pick, like, I don't know, 0. It found that one. Okay, 0.475, etc. So to the nearest hundredth, this one is 0.48. Remember, this one over here was exactly 5. So if you've got two places where the graphs cross, your guess should be close to the one that you're looking for. So I chose 0 because it's close to this one, because I had already found that one. Now, we've got to make sure that both of those answers make sense. I mean, if x is 5, looking at this, 12 minus 2 times 5, okay, that's 2, so it's positive. If it had made it negative, you'd say, well, that can't happen. You can't have a negative length. Okay. So this is going to run through what we just did. So there was the one with 5, okay, and previously I found the one that was 0.48. Okay. So in this, on the slides, I found the 0.48 one first. Okay, so 0.48 inches and 5 inches. Okay, number 3 says, if a drug is injected into the bloodstream, the percent of the maximum dosage that is present at time t is given by y equals 100 times 1 minus e raised to the negative 0.35 times 10 minus t power, where t is in hours and 0 is less than or equal to t, which is less than 10. After how many hours is the drug totally gone from the bloodstream? If necessary, round your final answer to the nearest hundredth of an hour. Okay, now notice we're given a range for t. So remember, that's our range for x. So this will be the x min and the x max. Okay, now notice we want to know after how many hours is the drug totally gone from the bloodstream. That means we want to know where y is 0. So we can use the single graph method on this one. So our solution. So we're going to the drug be totally gone from the bloodstream, so that means where is y 0? So we're going to have this expression equal to 0. So again, you can use the single graph method, or you can have this be y1 and y2 be 0. It's your choice. So the single graph method is appropriate. So let me go ahead and enter this into my calculator. So clear that. Second quit. Y equal Okay, clear. Let me give it a Y2 just because I don't need it. Okay, and then my Y1. Okay, 100. Open parenthesis. 1 minus second ln negative 0.35 open parenthesis 10 minus x, close that parenthesis, get out of the exponent, close that parenthesis. And let's go ahead and put that. Let's see if we can figure out some settings for the window. Now, these are the x's. So window, okay, 0 to 10. May as well keep the scale to be 1. Okay, the y min, again, let me be 0. Because of this 100, I'm going to let the maximum be left at 150. If you wanted to do, let me go ahead and change to 100. What the heck? So 100. And let's do calc. We're looking for the 0. And remember, we want it to cross the x-axis eventually. Oh, it did. It looks like it crossed it exactly at 0. So, left bound to 5. Sure, why not? Right bound. Let me see if I can take 11. What the heck? See if it'll do 11. Even though it's not on my screen. Ah, I got an error statement. So let's quit. Let's change my window. Let's let it go to 15. A little bit over. Okay. And then we quit. I really could have done calc, couldn't I? So 0. Okay, this time it should fall short there. Okay, my left bound 7.5, sure, why not? Right bound, I've tried 11 before. Let's see if it'll take it now. And notice where it's crossing the x-axis is between those two vertical lines. 10. So in 10 hours, okay, this 0 should be a little bit closer that way. So we use x min equals 0, and there I chose x max to be 15. Okay, so left bound of 7.5, right bound of 12. Okay, and again, 10. So after 10 hours, the drug is totally gone from the bloodstream. Do you think that's why the settings for T, where 0 is less than or equal to T is less than or equal to 10, that the drug has to be taken every 10 hours? Probably a little bit less than that, right? Every 8 hours for you allied health type people. That's the end of section 2.4.